Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we are here today again. So in this video, we are going to analyze frame with sidesway. Okay, based on example 3.3 that actually have been discussed last week in class. So we will detail all the procedure, okay, in order to calculate the member end moment for frame. Okay, so under this topic number 3, moment distribution method, we covers beam analysis as well as frame analysis. Okay, this is frame analysis. So in frame analysis, actually we have two types. We have non-sidesway frame, or we can also call it as non-sway frame, and we also have a sidesway frame analysis. Okay, so in sidesway frame analysis, actually for the solution, we combine both non-sway frame and sidesway frame in one analysis. Okay, in one analysis, and we actually continue we analyze based on some procedure which I can summarize as 4 main steps. Okay, the first step is okay, for the first step is calculating K and distribution factor. Number two is called as non-sway frame analysis. Okay, under this non-sway frame analysis, we have to do 3 things. Number one is FEM due to loading. B, we have to calculate end moment M naught, and C, we have to calculate restraining force R. Okay, that is step number 2. And then move to step number 3. We have to do sidesway frame analysis. And under this sidesway frame analysis, we have to do 3 things also, which is FEM due to delta. The previous one is due to loading. Okay, and delta prime. B, we have to calculate M prime from the distribution table. And C, we have to calculate R, restraining force. Okay, the under non-sway frame also restraining force, the label is R. Under sidesway frame, also called as restraining force, the label is R prime. Okay, and procedure number 4. It is okay, the last procedure, when we need to combine moment from two table. Moment from two table, we have M naught moment. M naught is moment. Okay, M naught is end moment from non-sway frame, and we have M prime end moment from sidesway frame. So we need to combine this, but for this sidesway frame, we have correction factor. So we combine all this under one equation called it is actually principle of superposition. And I have actually explained the derivation of principle of superposition in my previous video as well. Okay, so there are many video explaining about the frame, the concept of frame with sidesway, how we are actually deriving the equation called member end moment, final member end moment, considering both external loading and sidesway. So we have correction factor, in the equation. So the final equation is M final is equal to M naught plus R divided by R prime times M prime. So that is the final equation. Okay, so you have to follow all these steps. You have to follow all these steps whenever you want to analyze frame with sidesway. Frame with sidesway. Okay, before we start, we have to look at the diagram. Okay, in the diagram, we have to, you are given, actually we are given now, one frame, one is fixed, one is spin. A is fixed, D is spin. Okay, and this is unsymmetry frame. Okay, so we have to understand as well the condition of a non-sidesway frame. Okay, we can find it under chapter number 11 under topic frame. So actually the definition of non-sway frame actually is there are two. Okay, the definition. Number one, the frame is non-sway frame if it is properly restrained. Properly restrained. Properly restrained. Number two is symmetry. Number one is symmetry first. Symmetry. If the frame is symmetry due to loading, due to geometry, it is just non-sway frame. And another thing is, okay, properly restrained or fully restrained. Okay, this is the two condition. This is the two of condition of non-sway frame. Condition of non-sway frame. So other than this, okay, other than this, we have to consider, we have to calculate or analyze the frame by using all this procedure. Okay, there are four procedure. Start with K and distribution factor, because this distribution factor will be used in both table. Okay, step number two, we have to have non-sway frame. Non-sway frame. So we have to understand that non-sway frame is under this category. Under this category. So we have to, under this category, properly restrained. So we have to make the original frame as fully restrained frame in order to remove delta from original frame, because in actual due to loading, this is not symmetry frame. Due to loading also unsymmetry, due to geometry also unsymmetry. So so this frame actually we will get the moment, the member and moment which come from delta and external loading. So what we need to do first under step number 2, non-sway frame, we have to remove delta. Okay, because in original condition we have combination. We have combination. So we have to remove delta. When we remove delta, when we want to remove delta, we have to change the original frame to fully restrained frame. To fully restrained frame by putting an imaginary support. Okay, imaginary support at C, so that the frame cannot move to the right direction. Okay, so this is a case where the frame is tend to sway to right direction. If the frame is tend to sway to left direction, then we have to to put an artificial support at B, so that the frame cannot move to the left direction. Okay, so non-sway frame and then side sway frame. In side sway frame, we have to remove all external loading. We just need to calculate due to delta only. But in this case, since the frame that we analyze in table number 2 is also artificial frame, so we have to add prime, R prime. Due to R prime, so it will produce delta prime, and the moment will be M prime. So that is why we have the correction factor. Okay, so step number one, so label as part 1 here. So number 1, we have to calculate the correction factor, the stiffness factor. the stiffness factor. So in calculating stiffness factor, you have to be careful because we normally use two formula based on far end condition. Okay, we have 3 EI over L for a far end pin roller, and we have 4 EI over L for end fix. And based on this diagram, okay, between A and B, we use 4 EI over L. We use 4 EI over L. And between B and C, because both are internal, so we use 4 EI over L. And don't forget, BC has 2 EI, so we have to times with 2. Okay, and for CD, D and D is N pin. So we have to use formula to calculate stiffness factor considering far end pin. And considering far end pin, we use 3 EI over L. 3 EI over L. Okay, so we have 3K, we get 0.8, 0.8 EI, 1.6 EI, and 0.5 EI. Okay, and then we have to continue to calculate distribution factor. Distribution factor is K divided by total K. Distribution factor is K divided by total K. K divided by total K, distribution factor. And please remember, for N fixed, the factor is 0, the distribution factor is 0, and pin distribution factor is 1. And fixed distribution factor is 0, and pin distribution factor is 1. That is why for AB we get 0. For AB we get 0, and for DC we get 1. For DC we get 1. So the rest we have to calculate as usual. As usual, it is K divided by total K. Means that if we want to calculate DF for B, for BA, means that the total means BA plus BC. BA plus BC. BA plus BC. So we get 1.333 for DFBA, and BC automatically we know the answer because it is 1 minus 0.333, we get 0.667. 0.667. Okay, for distribution factor CB, DFCB, so it is KCB. KCB, total K join. K at C is CB and CD. CB and CD, so we get 0.762, 0.762, and another one will be 1 minus 0.762. 1 minus 0.7662. Okay. Okay, now we want to move to the second procedure, part number 2 here. Part number 2, it is called as non-sidesway frame or non-sway frame. Doesn't matter, both can be used, non-sidesway frame or non-sway frame. Okay, so we have to change the condition from sidesway frame, the original one, to fully restrained frame. To fully restrained frame by putting an artificial support at C, because we know that from the original diagram the frame is tend to sway to right direction, so we have to put one support at C so that the frame cannot move to right direction. So we put at C. So due to the pin support, there will be a reaction due to C reaction, because once when we have support, we have reaction, and this reaction we call it as restraining force. So this is restraining force. Restraining force. The label is R. Okay, even though this is pin, but we only focus on the horizontal reaction that is occur when we when we put the pin support at C. Okay, so this is now called as fully restrained. Fully restrained frame. In fully restrained frame, there is no delta. Okay, there is no sidesway. means no sidesway. Fully restrained frame means no sidesway. Means that in the frame the member in the frame will only deflect, not move to the right or left direction. Okay, this is fully restrained frame. Fully restrained frame. So of course we will analyze this. Okay, we analyze this to calculate R value later on. So we have to draw the free body diagram for this frame by putting reaction at the support at A, at D. Okay, so move to step number one. Step number one, we have to calculate fixed end moment due to external loading. Actually, under step number two, we are actually doing the same like what we have done previously under beam. Okay, it is actually the same process. When we have member, we have loading, we have to calculate the fixed end moment, we put in the table, and then we do distribution process. Okay, the difference is only due to step 2A, because in beam we have in frame we have to calculate restraining force. Okay, it is not occurred in beam. Okay, in beam we calculate and then we get the moment directly, just like that. But in frame we have to add additional step. After we calculate FEM due to external loading, we continue with distribution table, we get end moment due to external loading. Okay, and then we have to calculate R value, restraining force. So R value or restraining force is another step that you need to know. Okay, when we analyze frame with sidesway. Okay, so this frame has 200 kilonewton subjected, not at the center. Okay, this is 200 kilonewton subjected, not at the center, 2 meter from A, 3 meter from C. So using formula, so the formula is given in the appendix, so you have to use formula. So basically it is like this. Okay, this is A, this is B, this is L. Okay, the FEM is going to be like this. It is behavior, one negative, one positive. So formula A square B over L squared. This is P A B squared over L squared. Okay, so refer the formula. So we calculate the FEM based on the formula. So we get negative 144 and 96. Negative 144 and 96. Okay, fixed end moment. So this fixed end moment, these two fixed end moment is the first member end moment in the table. The first member end moment in the table. Okay, so we can start doing distribution. Okay, the first distribution, what we need to do is we have to find joint moment, and joint moment is opposite with member and moment. This is member and moment, the first member and moment in the table. Joint moment is opposite. So when joint moment is opposite, what we need to do is we have to okay, so what we need to do is we have to we put negative to change sign representing opposite condition. So it is BA plus BC. BA plus BC is the total moment. BA plus BC, so it is negative 0 plus negative 144. So total is 144. We times with factor 0.333. 0.333. So we get 47.144, 0.333. 0.333 times 144. Okay, it is 47.952. 47.952 Okay, so to get the other one, so what, because the total, these four value total must equal to 0. Okay, so once we get this, we should get this using two way. Either we repeat the process again to find the negative 144 and 47 point. Either once we 144 it is positive because this factor 0.667. Okay, we get 96.04. The difference between 144 and 47.9. Okay, this is just for first checking. Okay, for first checking. To join C, okay, just now we are doing join B. Join B. Now we move to join C. Join C. In C, okay, total moment is 96 and 0. But don't forget 96 is not the join moment. It is member and moment. So the moment times with is distribution factor is 0.762. Okay, so we get negative 73.152. 22.848. 22.848. Okay, next step. Next step is carry over. Next step is carry over. So under this step, so we have to be careful. We have to make sure that make sure the end condition refers to A and D for end condition. So A, because the factor is 0, we know that the n is fixed, and 1 at D shows that the n is spin or roller. Okay, because the factor for pin and roller, the carryover factor is 0. The rest is all 0.5. Only factors have to carry over. Okay, we have to carry over. Carry over. We actually carry to this, but the we carry with 0, we get 0. It is just like we don't carry the value, but this is because the factor is 0. So we carry over. So when we carry over the value, the factor is 0.5 for n fixed. For n fixed, the factor is 0. For n pin or roller, okay, we must carry the value to opposite join. Okay, it cross boundary. Okay, cross boundary. So this is why we get B, we get 47.92 by 2, it is 23. So this time we have to remain sign. This time we have to remain sign. Remain sign. We only change sign. We only change carry the value by 2. Okay. So we get 36.5 and 48.02 because we repeat the process again. So when we want to repeat the distribution process, we always refer to the value. Uh, okay, the previous value, the previous value. So we repeat the process. Okay, process and carry over process, the process in the table. Please also refer to other video, okay, in my YouTube channel. Okay, so we get M naught. So this is non-sway frame. Non-sway frame, this is fully restrained frame where we calculate FEM due to external loading only. We have removed delta from the system. So we have an extra step if we compare to beam. That is under step 2C, okay, or C or 3 lah. So it is, we have to calculate restraining force, because we have to calculate at the end of analysis the correction factor. So restraining force, we have to calculate restraining force using the moment that we get from table number 1, using analysis of frame and using the moment that we get from table number 1. Okay, so how to do that? We have to draw, we have to consider okay, the diagram, the free body diagram. The free body diagram, we have to put okay, the reaction at the support. Okay, AX, AY, MA. At A, because at A is fixed support, we put DX, DY, DX, DY, because at pin there are DX and DY. Okay, and then the pin support that we put, okay, to change from original frame to fully restrained frame. Okay, so from this, okay, set in mind that we are doing this because we want to calculate R value. So since R is in horizontal direction, and the delta is actually always referred to the column movement, so that is why we call it as shear equation. Okay, because when sidesway occur, it refer to column like this. This is the delta. Okay, the delta, this is length. Okay, and between delta and L, it is perpendicular. So delta actually occur which is perpendicular with L. It is actually referring to shear towards column. So that is why we call it as shear equation. So our main aim is to have the equation to calculate R, restraining force. Okay, so using the diagram, so refer back to the diagram. We have to write equation all in horizontal forces. Okay, R, we have R here, we have 350, we have AX, and we have DX, all horizontal forces. all horizontal forces. And using shear equation, total Fx is equal to 0. Total Fx is equal to 0. So we write one equation like this. 350 plus Ax minus dx minus equation. After having this equation, R value, and under this equation, known it is Ax and dx. We want to calculate x, and this Ax and dx can these two can be determined. To take out column separately. We have to take out separately. It is actually static equilibrium equation. Okay, we have to take column AB and calculate AX, taking moment at B, member AB taking moment at B, and we will get AX value. So we use equilibrium equation. And then we continue to analyze member CD, taking moment at C, we will get dx. So once we have determined AX and dx, so we will substitute into the shear equation. This is the shear equation that we have derived from the shear equation, and after calculated x and dx from column analysis, we substitute into the shear equation, and we get R is equal to 364.104 kilonewton. This is force. Kilonewton, horizontal force, kilonewton. Okay, and then settle part 2 A, B, C. Okay. Settle part 2. Part 2 A, B, C. A, B, C. That is non-sway frame. Non-sway frame, we analyze fully restrained frame. There is no delta, so we can calculate FEM due to external loading only. And after we get FEM, we put into the table and we do distribution moment, and the end moment from table we label as M naught. Okay, and then we do static equilibrium analysis. Okay, we analyze the frame, the fully restrained frame, by analyzing the free body diagram. We write shear equation. We use column analysis to calculate AX and DX, and we substitute AX and DX into shear equation. Then we get R value. Okay, now we will move to sidesway frame. Okay, we will move to sidesway frame. This is actually the most difficult part. Okay, the most difficult part, this one, this step. This is actually the part where you have to assume FEM due to delta prime, because we derive the equation, the final equation, by applying superposition method or principle of superposition. So we have in the equation we have fully restrained frame, we have sidesway frame. but the frame that we analyze under this step number 3 is not the real one. So it is based on assumption. That is why we can find that under sidesway frame, we label all the delta, the m, and r as delta prime, m prime, and r prime. Okay, we have to label that because we calculate or we do not know the delta. So what we can do is we assume FEM. We don't calculate the delta value. We assume FEM. So based on assumption, that is why we have correction factor. Okay, we move to step number 3, procedure number 3. This is sidesway frame. If the first table we analyze fully restrained frame. For second table, we will analyze sidesway frame due to R prime. Okay, so I have actually put explanation of the frame. It is sidesway frame due to R prime. Sidesway frame due to R prime. Table, it must be and I have explained why we have to analyze based on in the right direction because the sidesway, okay, from the beginning, the sidesway is going to the right direction. If the frame in the first place, the frame is tend to sway to left direction, then we have to put R prime in the other way direction. Okay, so this is R prime. So due to R prime, there will be delta prime, and the moment will be labeled as M prime as well. Okay, M prime as well. So by looking at this frame, so there are two columns here, column AB and column CD. Okay, member BC is horizontal member, and the delta for member BC is equal to 0. That is why we only analyze column AB and column CD. Okay, we will always analyze the delta which is parallel with member. So we are now focusing on AB and and CD. Both are vertical element. So the shear for vertical is horizontal. Okay, the shear for vertical is horizontal, perpendicular. That is why the delta prime we label as, okay, delta prime, which is the horizontal deflection at B, and also horizontal deflection at C. We label we assume that delta at B both are there. So from the formula to calculate FEM due to settlement of the FEM equal to negative 6 delta over L squared. This is prime. Okay, so this is the formula. 6 delta prime of L squared. Okay, why it is negative? Okay, look at column AB. Normally, when we have two column AB and CD, we can only assume one column, assume FEM for one column, and for another one we have to find the ratio. Okay, we have to find the ratio. So we choose AB to be assumed. So look at the behavior. Look at the behavior. This is perpendicular. This is delta prime. This is move to the right direction. Okay, column is vertical member. Beam is horizontal member. That is why when we analyze support settlement, we measure the vertical displacement. And now we are analyzing frame. We focus on column. So we determine the delta. The delta is actually perpendicular with the column. So that is why we measure or we mark the delta prime. We do not measure what is the value of delta prime, but we mark the delta prime. The delta prime is perpendicular with the member. Okay, so look at the new position of column after sidesway. It moved to the right direction. It moved to the right direction means the angle is positive, because angle or the chord rotation we measure from origin is vertical move to line. So angle I have also in my previous video today when okay, so if this is the behavior, FEM we the moment we push back both A and B, so that the column, the inclined column will move back to straight position. So this is negative. This is negative. This behavior is negative. That is why the assumption that we made, we have to put negative. We have to put negative if the frame is moved. If the frame to right direction, it is negative FEM. If the frame is moved to left direction, it is positive FEM. We measure the angle from original position to new position. Okay, look at the angle, whether it rotate clockwise or counterclockwise. In this case, this column, the column rotate. We have to apply formula for whether it is spin, whether it is for fixed end moment, we can use or we can assume we use both end fixed formula for all. Even though it is end pin, even though it is end fixed, so we use only one formula. Okay, I don't want to make you confused, so we only focus on one formula. Okay, now we apply FEM formula, FEM for AB, FEM for BA, and it is 6 EI delta prime over L squared. It is 6 EI delta prime over L squared. Okay, so the value is negative, so I have to actually put negative here. Negative, so it is 6 EI delta prime over L squared. 6 EI delta prime over L squared here. And then we apply the FEM formula considering both end fixed. So we apply the formula, it is 6 EI delta prime over L is 5. L is 5, so L squared equivalent to negative 100. Why it is negative? Because of the behavior. because the frame is in this position and we have to push this, so push this, so that the column, okay, the column will be vertical again. Okay, we'll go back to original position. It is vertical, because if we put different, we put different sign, okay, or wrong sign, means that, okay, what happened if we put, okay, it is the new position of column, and we apply positive FEM, what happened? So if we apply positive, means that we push the column forward. If we apply moment clockwise, so we don't want that. We want to apply moment to big to push back the column to straight position. That is why we have to apply negative value. So this negative is very important. Okay, we get the right behavior. Okay, if we put wrong sign, means we put the wrong behavior. Okay, so this is wrong. This one is wrong. Okay, because it will move to this. What we want is, we want this. Okay, we want the column to be straight again, straight vertical again. Okay, so we apply the formula. It is 6ei delta prime over L square equal to negative 100, and so we substitute, we rearrange back, so we get negative 100 times 5 square divided by L. Okay, we use this ei delta prime and we substitute into the formula to calculate FEM for CD, for member CD. For member CD, FEM CD is equal to FEM DC. FEM CD is equal to FEM DC. So it is, we use the same formula, except different. Except L is different. So 6EI delta over L squared. Now L is different. L is different. So we substitute EI delta prime into this equation, and finally we get the fixed end moment for CD, for member CD, equal to negative 69.444. It is negative. Why it is negative? Because the column is like this after sidesway, and we apply moment to push back, push, so that the column will go back to vertical position, straight position, not horizontal. Okay, so we have to check this. Okay, AB and CD have same behavior. Both move to the same direction, so both must be negative. Okay, so once we settle analyzing this, okay, we use the fixed end moment negative 100 and negative 69 put into the table, and we need to repeat the process again. Okay, so we put FEM that we assume for AB. For AB, it is negative 100, negative 100. AB and BA both have same behavior, same sign. So there is no vertical displacement at BC. That is why BC, for member BC, the delta is 0. The delta is 0. And for member CD, even though this is pin, so doesn't matter, we assume that and fix first, then we will continue the distribution, and we will carry the value to CD later on, and the total will be cancelled and we will get zero value here. Okay, so it is negative 69, negative 69, both are same. We start distribution. Okay, start the first distribution. Okay, for AB, since the factor is 0, so we leave it blank. And for For joint B, we have negative 100 and 0, means that the joint moment is 100. So times 0.33 times 0.6 is equal to 6.7. Total ni okay, total for joint C we have 0 for C for C and more 0. Total must be 0. And one, we have another one. It is is member and positive 69. Positive 69, negative 9. Positive 69. And next step is carry over. Next step is carry over. So we have to carry the value. We have to carry the value to opposite join. We use the factor 0.5, accept and pin. Accept and pin. So here we carry the value. Okay, cross and this. Okay, we do not carry CD to DC because the factor for the carryover factor for D is 0. Okay, so we do the process again and again, repeat the same process. So we get 16.65 and then we get 26 from 52, we get 36, we get 34.6 and 16. This 16, the factor is 0, so we do not carry the value and we just leave it blank. Okay, and then we repeat again. 26, 26, 26.4 is 0.333, so we get negative. Okay, negative 8.8 and then we get negative 17.648. Then continue for joint C. For joint C, we have joint moment. We get from negative 57. We total this. Okay, it is negative 51.781 and negative 16.201. We total this. Change sign. Okay, opposite condition. Okay, and then we get negative 0.828. Okay, and then we continue the process till the last distribution. Okay, until the last distribution. This one is the last distribution. Stop at distribution, and we have to total all the moment. Total all the moment value start from the first moment in the table. Okay, that is from fixed end moment. So total, then we will get this M prime. So there are 6 M prime. Okay, DC is 0 because it is pin. So this is correct because pin has 0 moment. Okay, then we use this to calculate restraining force R prime. Okay, so under this step, it is actually the same process like what we have done to calculate restraining force R. We just need to repeat. Okay, however, we have to draw the free body diagram for sidesway frame based on R prime, and then for fixed support and pin support, we have to put the reaction. Based on the support condition. Then we again write the shear equation, and this time the shear equation will be referring to this one, this diagram. We don't use the same shear equation, we derive the shear equation. Okay, we derive the shear equation from the free body diagram. Okay, so this is sidesway frame. This is sidesway frame. So we write the new shear equation. So under shear equation, we will get R prime value. Okay, under this equation, this is two problems because we have A prime X and D prime X. We have these two, A, X and DX. Okay, and then to get this, we have to do column analysis. We have to do column analysis. So take out column AB, take out column AB. So when we take out column AB, so NA and AB and A, this is NA and NB, both have moment we get from the table. Okay, so use this, take moment at B, take moment at B, so we do the same for D. So only D has no moment. We only get moment from MCD in the table. So we calculate D prime X value, this AX and D prime. Okay, we substitute into the shear equation. We substitute into the shear equation. Okay, the shear equation. So we get R prime equal to 35.803. Okay, so this is the final part, okay, or step number 4. So where we have to find the total moment. The total moment. Why we have this also I have discussed, okay, in my video. So please find this derivation. Okay, finally this is the equation. The equation M naught is the n moment. So this is from table number 1. This is from M prime is from table number 2. We have correction factor R divided by R prime. R, the upper one, R. We get from table number 1. Table number 1, shear equation for table number 1, and another one is R prime, is actually we get from shear equation from table number 2. Okay, so we use this equation, we produce one equation. The correction for use this equation external moment. Okay, the total member and moment. Okay, so having this, we can actually sketch the bending moment diagram directly without shear force diagram. Remember that the shear force diagram is when we want to calculate the maximum moment in the bending moment diagram. And actually, without the shear force diagram, we can also draw the bending moment diagram. So we jump to bending moment diagram directly by using the moment direction. Okay, so we can sketch that one. AB is negative, BA is negative, and then last one is 0. Last one is 0. So means that when we draw the diagram, so we will get like this. Okay, so the moment is negative, and then negative, positive, and negative 0. Negative 0 means that the point will be here and here, and somewhere here, and here. Okay, so this the AB, for AB we just need to join this dot. Okay, so this is positive, this is negative. Okay, for BC, 1 point is like this. And actually, because under BC we have point load, so we do not know the value if we don't have the shear force diagram, but doesn't matter. It is maybe we do not know the exact position, but this is good enough. Okay, so the moment we get from table, okay, same goes to, see, this is UDL, right? Point load or UDL? It is actually point load. If point load only, point load. Okay, point load only. So for CD, okay, CD, okay. So for CD, the diagram should be this. Should be this. Okay, so negative, positive. This is negative. This is also negative. Okay, the value is the value in the, so this is 38 388.215 3.15 to 1 and 1 and 815.019. 815.019. So this is bending moment diagram without shear force diagram. And only the maximum moment we do not know the value, because we can only get that from shear force diagram. And if we want to do that, we can only analyze member BC to determine the value. Okay, so this is actually the process in frame with sidesway. So we can summarize under four main procedure. Okay, this is the four step that we are going to use every time we want to analyze frame with sidesway. Okay, K and DF. Okay, so the first step and last step is very simple. We need to understand for step number 2 and step number 3, because under step number 2 we analyze non-sway frame. It is a fully restrained frame. We remove the delta, so we calculate FEM, we calculate N moment M naught, and additional step is R value, which is restraining force. We calculate based on static equilibrium analysis. Okay, we calculate based on shear equation and analysis of column. Okay, and then we move to sidesway frame. So this frame is imaginary frame. This is not the real one. So subjected to R prime. So we have to calculate to assume FEM due to delta. And we have to use that FEM in the table, and we find the end moment, which we label as M prime. And then we repeat the same process, just like 2C process. We repeat to calculate restraining force R prime under step number 3. So once all this, we have calculated all this, we just need to substitute into the formula. Okay, it is MF equal to M naught plus correction factor kali times with M prime. So we get the moment for the frame with sidesway. So in the frame, we don't have to calculate delta value. We do not know the delta value, and we do not need to calculate the delta value. So what we do is only assumption under the sidesway frame analysis. We made assumption, and then we the final one, we find the correction factor. Okay, so that is actually frame analysis subjected to sidesway, frame with sidesway. Okay, so before we end session today, I just want to highlight, actually there are another example. Okay, under the OneNote class notebook, frame 3.4 is actually this type of frame where we have one inclined column, and another one, frame 3.5. 3.5 is another type of frame where we have two inclined column. So basically the process are the same, except under this case, beam also have the delta. Beam also have delta, so we will have in table number 2, we have the fixed end moment due to delta for all members A, B, B, C, and C, D. Okay, so I think that's all for this session. I hope you understand. If you have any more question, okay, please tell me, so I will arrange a session for to answer that question, inshallah. Okay, so hopefully this will help you to understand moment distribution method, frames with sidesway analysis. And please don't forget to watch also series number 1 this morning, beam analysis with support settlement. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.